Welcome back, Semester Astronomy. Good to see everyone. We're here for our final section of the Section 3 notes, our solar system. And if you're asking, Mr. Krug, you look different. How'd you get that hip haircut since everything's locked down right now? Well, Mrs. Krug actually gave me this cut right here. So, fellas, my advice, have your lady friend or guy friend, it's 2020, have them learn how to cut your hair. First couple times won't go so well, but it's worth it in the long haul, because if we ever get quarantined again, then you can be sporting a cool new do while all your friends are looking real shaggy. So we only have a little bit of the notes left to go. We're going to talk about Pluto and the outer solar system. And then I'm going to have some questions put up for you. And this video is not going to be locked, so you can go back and forth between YouTube and the questions which are on Google Classroom. And as always, please do follow along with the PDF, or what's even better, have your notes printed out and then follow along with them as you go. This time we're going to do the questions a little bit different, but I'll get to that in just a little bit. So let me go ahead and share my screen. And let's just review where we were at. During our first lecture, we talked about the overall layout of our solar system and also of the inner solar system, which is a group we would know as the terrestrial worlds: Mercury, Venus, Earth, and Mars. Our second lecture took us past the asteroid belt and on to the realm of the gas giant Jovian worlds: Jupiter, Saturn, Uranus, and Neptune. So today we are going to begin at the bottom of page 8 here with the former planet Pluto. So you can check out its diameter. Its distance from the sun would be 39.4 AUs. And if you remember an AU, that stood for astronomical unit. It's a great distance unit to use to measure within the solar system. 1 AU would be the distance from the sun to the Earth. So if Pluto is about 40 AUs away, that means it's about 40 times farther away from the sun than the Earth is. So because of this great distance, it takes little Pluto almost a quarter of a millennia to make one full revolution around the sun. For the longest time, we thought Pluto just had one moon, Charon or Charon, but we now know of at least 5 moons orbiting around it. The mythologies of Pluto and Charon kind of work together. In mythology, Pluto was the lord of the dead or the underworld, and Charon was the boatman that would ferry people back and forth across the river Styx. So this was kind of a neat location because most of us have grown up since the time of Voyager 2, which sent back the first pictures we'd ever received of Uranus and Neptune. So Pluto was really the last major solar system body we know of, at least so far, to actually receive direct pictures. And that happened in 2015 when NASA's New Horizon mission zipped by at least one side of Pluto on its way to the outer solar system. And we ended up finding here a much more dynamic world than astronomers were envisioning. It is about, they think, a 50-50 rock-ice mix, like a lot of Jupiter's Galilean satellites or Neptune's moon Triton. But it's very diverse. It seems to have floating mountain ranges that are suspended on a slushy layer of ices, and it probably even has a thin methane atmosphere. So the big controversy always comes up around Pluto and its planethood status. Whenever I have public sky shows and I'm taking questions afterwards, probably the #1 question that I get, even bigger than, hey, Mr. Krug, do you think aliens exist, is why is Pluto no longer a planet? So first I'll give you the official reason, and then I'll tell you a good story about how shady politics entered into play. So these are the official reasons that Pluto was demoted from planethood back in 2005. For starters, Pluto does not orbit the sun on the same plane as the other planets do. So if you imagine my fist being the sun, all 8 planets orbit more or less on the same invisible surface, give or take a degree. But Pluto actually orbits like this at a very high angle. Think about maybe a glass patio table you have on your back porch, which you're starting to use now that it's finally getting warmer. You know how there's the hole in the center of the patio table for the umbrella? Pretend that there's a yellow ball sunken down into that hole. And the planets are 8 different size marbles rolling around that ball at different distances. So they're at different distances, but they're on the same plane. Not Pluto. Pluto orbits at a very, very high tilt. So that was reason number 1. Number 2, with Pluto, we run into a composition issue, what it's made of. It's not rocky like the inner planets Mercury, Venus, Earth, and Mars. But at the same time, it's not predominantly gaseous like Jupiter, Saturn, Uranus, and Neptune. As I mentioned, it's about a 50-50 rock-ice mix, like a large moon like Ganymede or Callisto. Number 3, its largest moon, Charon or Charon, is almost as big as it, and no other planet has this happen. So sometimes astronomers have actually dubbed Pluto a double planet system. But the real nail in the coffin, the real deal breaker, was number 4. Astronomers started to find objects beyond Pluto that were almost as big, and in one case, perhaps even bigger than it. So the first deeper solar system object they found was named Sedna. But then astronomers a few years later found this object, which was initially dubbed Xena after the character Xena Warrior Princess, played by Lucy Lawless on television, proving once again that most astronomers are kind of nerdy. But then it was officially named Eris, which was the Greek goddess of discord. Now, if you compare the diameter of Eris here to what I showed you for Pluto, notice that Eris is slightly bigger. Now, I did just read an article that said, well, Eris is technically smaller, they now found, but it's really, really close. So astronomers basically faced a dilemma. If you keep Pluto as a planet, you need to start naming these more distant objects planets as well. And by now, we'd be up to 15 or 16 planets. Or the other option is draw the line in the sand, or in this case, the vacuum of outer space, at Neptune. And Pluto is now the first of these more distant solar system objects. And there could be hundreds of them, if not thousands. And that's what astronomers chose to do. Now, that's the official story. Here's the shadiness behind the story that goes to show that science isn't always quite as objective as scientists would lead you to believe. A former student teacher of mine had a professor at Penn State that was a member of the International Astronomical Union. This is the group of astronomers and scientists that actually got to vote on Pluto's planethood back around 2005. And it might surprise you to learn the very first vote they took, Pluto overwhelmingly passed its test to maintain planethood. Most of the astronomers at the meeting wanted Pluto to be a planet, but that did not please the handful of astronomers who were running the conference. All of them very much wanted Pluto to be demoted from planethood. So here's how the shadiness went down. Throughout the conference, they secretly got a hold of the other men and women there whom they knew felt the same way they did about Pluto. And they said, hey, stay here until the very end of the conference, and we're going to hold a second emergency vote on Pluto. But they only told those scientists whom already agreed with them. And someday, if you ever go to a professional conference, they usually span multiple days, and people don't usually stay till the end. Some people have to get back early, some people have to catch flights. And so gradually, the attendance at this conference shrunk down. So finally, at the very end of the conference, without any warning, they re-held this vote, and this time Pluto was demoted. A lot of astronomers got really furious about this. I believe there used to be a clip on YouTube showing 2 astronomers getting into a fist fight on television about it. But so far, despite there being different rumors every year about it coming back, Pluto is not considered a planet. Now, we're going to do something different this time. We're going to take a break partway through and ask some questions, because get this, there's a chance that some students are just fast forwarding to the end of the videos and answering all the questions. I know, it's totally shocking, and you would never do that, right? But we still need to do this just for the couple teens that maybe aren't quite following the rules. So I'm going to stop the share. And so at this point, everybody, please do open the questions in Google Classroom, and I'm going to take you through just a few of them. So here we go. Number 21. This object was demoted from planethood in 2005, and has been a source of contention amongst astronomers ever since. Feel free to pause the video now and answer number 21. By the way, I'm drinking my coffee today from my Berenstain Bears Big Hug mug. Love it. Number 22. This probe sent back the first close-up pictures of Pluto, revealing a dynamic world of floating mountain ranges and a methane atmosphere. Number 22. Also drinking my water here, cutting my coffee intake with some water, keeping it real. Drink your water, teens. Very good for you. Okay, number 23. Look at the choices I've just given you. Of those choices, this is one reason why Pluto was not demoted from planethood. So when you look at your choices, 3 of those choices we just went over, but 1 is made up and not accurate. Pick that choice for number 23. Number 24. The discovery of this minor planet forced astronomers to reconsider Pluto's planethood status, as it may even be larger than Pluto itself. Number 24. All right, everybody, let's get back into the notes just for a little bit. I'm going to share my screen again, and let's finish up this page and then do a little bit of a review. So I added this section a couple years ago. I used to call this section the solar system, but notice I now call it our solar system, because we know for a fact now our solar system is but one of many. And think about how rapidly astronomy has changed. When Mr. Krug had just started high school, and Mr. Krug is like older than you, but not crazy old yet, just like decently old. When I started high school, astronomers had just found their very first extrasolar planet. Now that all of you are in high school, astronomers already know of over 5,000 extrasolar planets. So that means in addition to our 8 planets going around our sun's soul, there's at least 5,000 more out there. And that's just the tip of the tip of the tip of the iceberg. So what does this word actually mean? Well, if we break it down Latin style, extra would mean outside or beyond, and solar would mean our sun. So this basically refers to planets outside or beyond our sun, usually orbiting other stars. And astronomers have been very successful with this. There are at least 8 methods that have been used so far to find extrasolar planets. And you might think of an astronomer just sitting in front of a huge telescope looking through a little eyepiece, and then he or she would see a tiny little dot orbiting another star. That has happened very rarely so far. The last time I checked, out of those 5,000 or so planets, so far, less than 10 have been directly observed. But you can see a couple of those pictures online, and it's super awesome. Most of them so far have been found indirectly. For example, measuring the slight change of light output as a planet passes in front of it. Or secondly, measuring the wobble of a star as a planet slightly tugs on it. Here I have pictured not the Hubble, but the Kepler Space Telescope. And sadly, it went offline a couple years ago. It stopped working, and NASA could no longer fix it. And it only worked a couple years compared to Hubble's 30 years. At the time of this video, Hubble just celebrated its 30-year anniversary in space, which is insane. But here's how successful Kepler was. In a few short years, it confirmed around 3,000 extrasolar planets. And here's the doubly crazy part. Kepler was not even scanning the entire sky. It was usually only focused in one constellation called Cygnus the Swan. That many planets in just one constellation. Now, so far, most of the planets that have been found are called super Jupiters, which means they're anywhere from 2 to 4 times bigger than our biggest planet, Jupiter. And once you hit this upper range, everybody, you really start to get into that gray area between a big planet and a small star, or what we might call a brown dwarf. So most of the planets have been very large, so we assume they are made of gas and dust like our Jovian planets. But the methods astronomers use are getting better and better, and the planets they're finding are getting smaller and smaller and smaller. They're already finding planets around the size of Earth, if not a little smaller. And what's really exciting is they're beginning to find them in the Goldilocks zones of other stars. You might remember from lecture 1, this is that special area around the star that's not too hot, not too cold, but it's just right for liquid water and life. So I think there's a very good chance you all are the first generation living who's going to know for sure that we are not alone in the universe, and we might even find that out within your lifetimes. Okay, let's take a quick break and answer question number 25, which will be the last question for this part of the notes. Here we go. Question 25. This is a term for a planet orbiting a star other than our own sun. Question 25. Okay, I wanted to have 10 questions, and we're basically out of notes. So for these final 5 questions, let's review just a little bit, and let's head back to the beginning of the notes. I'm just going to ask you questions on a couple key concepts. So here was page 1 of the notes. We learned about the birth of our solar system. We also learned about the 2 groups of planets, along with the minor planets, which comprise our solar system. So that's what we learned on page 1 of the notes. So let's have a couple review questions. Number 26. This is the idea for how our solar system began around 4.5 to 5 billion years ago. This is the idea for how our solar system began 4.5 to 5 billion years ago. Question 26. Question 27. As a group, the tiny rocky worlds huddled very close to the sun, Mercury, Venus, Earth, and Mars, are called what? Number 27. Number 28. This lies in sharp contrast to the large gas giants lurking very far from the sun, Jupiter, Saturn, Uranus, and Neptune, which together as a group are called what? Number 28. Okay, your final 2 questions for this review will cover very special terrestrial worlds. So you might remember from lecture 1, we talked about the planets Mercury, Venus, Earth, Earth's moon Luna, Mars, and Mars's 2 moons Phobos and Deimos, which then led us up to the asteroid belt. So your final 2 questions I think should be fairly easy. Question number 29. This is the only planet found directly within our sun's life zone, habitable zone, or Goldilocks zone. Question 29. And finally, question 30. This planet, the most Earth-like of worlds in our solar system, is a future colonization site for human beings, as we must expand beyond our home world out into the cosmos. Question number 30. All right, astronomy, that concludes our 3rd and final lecture on section 3, our solar system. I hope you've really enjoyed it. Thanks for sticking along. I hope that this gives you a little better understanding of what we're covering here in the notes. And just don't forget, everybody, if you haven't done so, answer questions 21 through 30 in Google Classroom right now. Thanks for coming by, everybody. Peace.